base, oh, we usually call it base B. Here they're using A. So our base is A, and our exponent is N. And when you're dealing with powers, um, all this means is that you are multiplying this by itself n times, right? So if I have x squared, it's x times x cubed, x times x, right? By the way, if I have if I have like the number 4, is that a power? Yeah, it is, isn't it? All numbers are powers because any number, or I should say, if there's not an exponent there, what's the power? One. Okay. We just normally don't put it there. All right, let me run through the properties. Product of powers. When you're multiplying by the same base, you add the exponents. For example, 3 squared times 3 to the fifth, you add the exponents 2 plus 5 or 3 to the seventh. Okay. When you're when you have a power raised to a power, you are think of it as distributing. Just like if you had a number in front of parentheses, you have to distribute it. If you have an exponent outside of parentheses, you think of it as distributing. It really isn't. You can't. There's no mathematical term for distributing the exponents, but think of it as distributing. So, for example, if I have 2 to the third and it's raised in parentheses to a 2, then you're going to multiply the exponents 2 to the 3 times 2 or 2 to the 6. Power of a product. Now, again, a lot of students make this mistake where we have different bases and they forget that there's an exponent of 1 there if there's no exponent. Okay. Even with numbers. Then again, you're going to distribute that exponent to each one of those bases. So AB to the M is A to the M, B to the M. Or in other words, if I have 4 times 3, each one of those gets multiplied to the exponent of 1, right? So 3 times 1 is 3. 3 to the 1 times 3 is 3 cubed. And yeah, my brain's not working this morning. I can't do that in my head. It's a big number. Be careful again. If I have something like 4x raised to the second, again, don't forget that there's a 1 to that 4. This is what I was telling about. A lot of students make the mistake. They forget to multiply that number's exponent. So this would be 4 to the second, x to the second. Okay. This happens a lot with students. Negative exponents. You can never leave an answer with a negative exponent. It's very improper. Okay. If I have a negative exponent, a to the negative m, then I have to put it in as 1 over a to the m, and I make it a positive. Now, there's a disclaimer that a cannot be 0 because um, if I cannot divide a number by 0, right? So basically, what you're doing on this is you're taking the reciprocal and making the exponent positive. because sometimes they'll have that negative exponent in the denominator, so you would have to flip it. Try to think of it as a fraction and taking the reciprocal. Any base raised to the zero power is one. Example: 100 to the zero power is one. Anything raised to the zero power is one. Quotient of powers with the same base, I subtract the exponents. A to the m divided by a to the n, I subtract the exponents m and n. For example, 3 to the fifth divided by 3 squared is 3 to the 5 minus 2, or 3 to the 3. If they're different bases, you have to distribute that exponent to each one in the numerator and the denominator. Okay. For example, if I have a divided by b raised to the power m, it's a to the m divided by b to the m. 3/5 raised to the fourth, 3 to the fourth divided by 5 to the fourth. Again, way too early in the morning for me to compute that. All right, so we got some examples of I believe, each one of these properties. So let's go ahead and do that. Here I have um, product of powers where I have the same, I'm going to have the same basis. I add the exponents, but be careful, there are different bases in here, right? I suggest that you guys regroup this. Okay. Remember, multiplication is commutative. I can switch order, right? So I'm going to put my numbers, group my numbers, then I'm going to group my y's, or x's, sorry, x squared times x to the fourth, and then we have y cubed times y squared. Now, I know that this is, kind of an easy problem. It's short. You could probably do it in your heads right here. But when you get into lengthy problems, grouping your different bases together really does help. Okay? So now that I have the same base, I'm multiplying so I can add the exponents. So I have my 4. I have x squared plus 4. That gives me x to the 6. Y to the 3 plus 2 is 5. Let's see, number 2. I got my numbers together. I got a 3 and I got a 2. Going to put my x's, group my x's together. Get an x cubed and an x to the fourth. Going to group my y's. I got y to the fifth, y cubed. Now the numbers I can multiply together, right? 6. I have to add my x exponents and my y exponents. So I have x to the 3 plus 4 is 7. And then I have y to the 5 plus 3 is 8. I have exponents outside of the parentheses. So I'm going to think of it as distributing it over the parentheses. So I have x to the 3 times 2, x to the 6. X to the 3 times 5 is x to the 15th. And here I have the power of the product because I have different bases, right? Be careful. If I put a 1 there so I don't make mistakes, I'm going to have to distribute that 3 to each one of the exponents. So I have 2 to the 1 times 3 is 3. X to the 4 times 3 is 12. And if you want, you can multiply that 2 cubed out. 8x 12. Number 6, that 3 has an exponent of 1. I need to distribute that 4 to each one of the exponents. So I get 3 to the 1 times 4, 3 to the 4th. X to the 2 times 4 is x to the 8th. Y to the 5 times 4 is 20. And it really doesn't matter on these problems to multiply that number out, but when we get into simplifying fractions with, you're going to have to multiply it out. 3 times 3 is 9, times 3 is 27, times 3 is 27 times 3 is 91. Must need more coffee. I spilled my coffee. All right. Number 7, negative exponents. Um, when I'm dealing with negative exponents right away, you know you're going to have probably a fraction. But I'm going to go ahead and group because I'm going to have to apply two properties here. I'm going to have to apply the product of powers first, and then I'm going to have to deal with any negative exponents I have. So I'm going to regroup. I have x cubed times x to the 4th. My y's, let's see, I got y to the negative 2 times y to the 6th. That leaves me with x to the 7th, and y to the negative 2 plus 6 is y to the 4th. So actually, my answer ends up with no negative exponents. I'm done. Number 8, let's see, I have my x's. X squared times x to the 5th. And my y's, I have y to the negative 3 times y to the 6. And I got my 7 out here. Okay, so I have 7 times x to the 2 plus 5 is 7. No, that's negative 5, right? So that should be to the negative 3. And then y to the negative 3 plus 6 is y cubed. Now I'm going to have to deal with that negative exponent because I cannot leave negative exponents in my answer. So I'm going to put this all over 1. And my 7 stays where it's at. My x to the negative 3 I'm going to put in the denominator, make the exponent positive, and then keep my y cubed where it's at. So there's my answer. All right, number 9. Let's see. I have my 3 x to the second times x to the 0. And then my y's, I have y cubed times y cubed. Let's see, this is 1, x to the 0. So anything times 1 is itself. So I have 3x squared, or think of it as 2 plus 0. Y to the 3 plus 3 is y to the 6. No negative exponents. Good to go. Now, notice I have the entire quantity raised to a 0. So this is all going to equal 1. Okay. Um, let's see. You could do this a couple of different ways. We have x to the, now quotients with the same base, you subtract the exponents, right? So I have x to the 5 minus 2 and y to the 3 minus 1, which equals x cubed over, or not over, and y to the 3 minus 1 is 2. No negative exponents. Good to go. Number 12, I have x. Now, there's a 1 there, right? X to the 4 minus 1 times y to the 2 minus 5. That equals x cubed times y to the 2 minus 5 is y to the negative 3. Have a negative exponent, so I'm going to put that over 1. So I have x cubed, stays where it's at, and then y is going to go in the denominator, change the exponent to positive. #13, power of a quotient. Let's see, these have exponents of 1. So I need to distribute the 3 to every exponent there. So I have 3 to the 1 times 3 or 3. X to the 1 times 3 is 3. And y to the 5 times 3 is 15. No negative exponents to worry about. Good to go. Okay, number 14. Before I you could do this a couple different ways. You can distribute and then deal with the subtraction of exponents. I'm going to subtract my exponents first, then distribute that forward. Remember, I can do things in the parentheses first. So I have 5 times nothing to do with the x, and then time or over, or actually times y to the 6 minus 2 is 4. Still have to distribute the 4. There's a 1 there. There's a 1 here. Distribute the 4 to the exponent. So I get 5 to the 1 times 4 is 4. X to the 1 times 4 is 4. And then y to the 4 times 4 is 16. No negative exponents to worry about. Good to go. Now, I could have distributed to every exponent first and then subtracted the y exponents. It's up to you. 15, Distribute the exponent, 6. I get a to the negative 12, b to the 24. Have a negative exponent to worry about, so I'm going to put it over 1. B to the 24 stays. A to the negative, well, actually change it to positive because I'm putting it in the denominator. Another way you can do these, you could leave it as a fraction. Let's see, I got 8 fourths. What is 8 divided by 4? Positive 2, right? A to the 6 minus 4. A to the 6 minus 4 is a squared. It's a positive exponent. It's going to stay in the numerator. And then I've got c to the 9th. And actually, since I don't have any negative exponents, I could just leave it as 2a squared c to the 9th. Okay, 17. Now, you're going to have to distribute that for exponent first because this is not in parentheses. Bless you. So I have x to the 2 times 4 is 8. Y to the 4 times 3 is 12 over x cubed y squared. Now I'm going to have to subtract the exponents. So I get x to the 8 minus 3, x to the 5th, y to the 12 minus 2, y to the 10th. No negative exponents to worry about. Good to go. Let's see, I'm going to put exponents of 1 there so I don't mess it up. Distribute that 3 throughout. So I have 5 to the 1 times 3 is 3. X to the 1 times 3 is 3. And y to the 4 times 3 is 12. No negative exponents to worry about. I'm done. And finally, let's see, all of this is raised to the 0. So this equals 1. X to the 5 times 3 is x to the 15th. Questions, comments, concerns? Does that give you enough? I even gave you a couple of different ways to do these. Hopefully, that'll give you enough to do the worksheet, your practice work.